Hello everyone and welcome to this lecture. In this lecture, I'm going to walk you through the code that can perform some color spaces manipulations. So simply put, we're going to walk you through kind of the steps that can convert an image from BGR color space or blue, green and red color space to, let's say, a HSV or hue, saturation and value. And we're going to learn how can we convert an image from a colored image into a grayscale image. And we're going to see how can we split an image as well from just an RGB color space, which is going to create different channels. We're going to kind of separate the three channels from each other. And we're also going to learn how can we merge them together. How can we take these channels, the RGB channels, and merge them together to come up with the original image back again. All right, so let's get started. So first, we're going to, as we have done before, to import mainly the important libraries. So we're going to import matplotlib.image as mpimg. We're going to import matplotlib pyplot as plt. We're going to import numpy as nnp. Again, mainly we use numpy for numerical analysis. And obviously, we're going to import OpenCV. So if we press Shift Enter, looks good. The next step is we're going to get the image. So the image is available here through this link and is attached as well in the course package. So let's take a look at the image. So actually, we don't need to have this again, but what we could do here, we could simply use OpenCV to read the image. So the image that we have is called self_driving_car.jpg. So if we press Shift Enter, here we just loaded the image and now we have all our images captured here within the image. Let's go ahead and check the dimensions of the image. So we're going to say, okay, image.shape. That should give us the dimensions or the shape of the image. So we have 426 pixels by 640 pixels. And obviously it's a colored image. That's why here we have three channels. Again, for red, green, and blue. Shift Enter, here we go. Afterwards, here we wanted to plot kind of, like how many pixels we have in the height, how many pixels we have in the width. So we say, okay, print height equals 2. And then we're going to take the image.shape of 0, which is simply we're going to obtain the first element in here. And we're going to plot as well how many pixels we have kind of, as a string in a way. So basically the output will gonna be, if we're on the cell, the output gonna be height equals to 426, which is the value captured in here, which is coming from the first element within our tuple. And then we're gonna say print width equals to int image.shape1. That will obtain the next element, which is 640. So we're gonna plot width equal to 640 pixels. All right, looks great. The next step, let's go ahead and actually visualize the image. Let's see it. So we're going to say, okay, cv2.image_show, and we're going to place a title to the image. So the title here is self-driving car, and we're going to pass along the image that we already loaded here or read using OpenCV before. All right, and then afterwards, we're going to use wake key, destroy all windows. So Shift Enter. Here we go. This is simply the image that we're going to use to kind of perform some manipulation to it. All right, again, press Enter or any key that should kind of destroy our window. So let's go ahead and use, here I just wanted to show you kind of show a very important point within OpenCV, that OpenCV, when it reads the image, the order of the RGB channel is kind of a little bit kind of reversed in a way. That's why if you, for example, load the image using OpenCV here, so here we used OpenCV to actually read the image, okay? If we stay within OpenCV, okay, if we try to show, let's say the image here using OpenCV, everything was great. So if you actually run it, we came up with the image colors looks perfect. Why? Because you load the image using OpenCV and you actually show it as well. So we use cv2.image_show using OpenCV as well, so that's good. However, if you try to mix them, if you try to, let's say, use matplotlib using plt.image_show, if you press Shift Enter, you will find that the colors kind of are messed up. It's the exact same image, everything looks okay. However, the colors are messed up. Why? Because the the order of the B and G and R channels are reversed within OpenCV. So if you try to load the image using OpenCV and then show the image using Matplotlib, you will find the colors are reversed. However, if you stayed within OpenCV, then you should be okay. Then you should be good. All right. Again, that shouldn't confuse you. This is just, kind of an overview if you wanted to, or just a hint if you wanted to mix kind of two packages or two libraries. All right. So the next step is we're going to say, okay, let's explore some pixels. So if you go to the image and then you select any pixel, so let's say 220 and 350, that should give us what are the values of the actual pixels within that specific location within our image. So the return out of this will gonna be fed into B, G, and R, and then we can simply print them. So Shift Enter, that will give us the actual values within this specific pixels. So you will find that there is the values of the BGR channels is 120, 176, and 127. If you, let's say, for example, change it to 230 and maybe let's say 450, Shift Enter, you come up with different values. These are the actual values of the pixels. And again, because it's a colored image, we've got three channels. The next step is let's go ahead and actually convert the image from colored space into a grayscale. So what we're going to do, we're going to say cv2.cv2 color. We're going to pass along our original image or our given image, our colored image. And we're going to say, okay, cv2.color underscore, we're going to convert from BGR to gray, which means I wanted to convert from colored image into a grayscale image. And that will be captured here within the gray image. And afterwards, again, we're going to use OpenCV to show the image. So we're going to say cv2.image show self-driving car in grayscale. That will be simply our title. And we're going to pass along our gray image, which is the image after the conversion. Shift Enter, here we go. So here we have the image and it has been converted from colored, from colored form into a grayscale format. Press Enter to destroy it. And then we can take a look at the actual shape of the image. So we're going to say gray underscore image dot shape, Shift Enter. That should give us the dimensions. And if you guys take a notice here that the number 3 here has been kind of removed. So if we perform the exact same process on the original image, we actually obtained 426 by 640 by 3, which makes sense because here we have a colored image. However, here we have only grayscale. So in grayscale, we only have one channel, and that's why we have only the kind of a single, kind of one-dimensional matrix. All right, or I'm sorry, two-dimensional matrix that has the values of the pixels and values of the rows, but we don't have multiple channels as in the case of a colored image. And again, here we can pick any pixels, and that will give us kind of the value of the pixel within that specific location. If you change it, let's say to 350, 180, Shift Enter, that will give us again the value of the value of the color within that specific pixel. All right, okay, looks great. The next step is we're going to convert from RGB to HSV, okay? So first, we're going to read the image, so self-driving car, and then we're gonna show the image as well. Afterwards, we're going to use cv2.cvt color. We're gonna pass along our original image, and we're gonna use the conversion here. And instead of converting from BGR to grayscale, as we have done before, here we're going to use BGR to HSV. Again, we're gonna show our HSV image, and let's take a look at it. So Shift Enter, here we go. So here we actually viewed our image, which is our original image, along with the HSV image. If you guys can see, it's a little bit hard to kind of interpret what's happening here. So let's go ahead and actually kind of separate the channels. Let's take the HSV image and take, let's say, channel, the hue channel, the saturation channel, and the value channel. So if you select all and 0, that should give us kind of the first layer within our image. That would be the first channel. Again, please bear in mind that we use indexing starting from 0, and then the next one will gonna be 1, and then the next channel or the third channel will have an index of 2. Shift Enter, here we go. This is our hue channel. If you guys can take a look at it. Again, it's BGR, they are very easy to interpret with humans, right, with our human eye. However, here, it's a little bit difficult to actually make an interpretation out of an HSV channel. So if you press all and one, that will be our saturation channel. If you guys take a look at it, this is our saturation channel. If we take a look at it, this will gonna be our value channel. If we mix them together, that will give us the image in an HSV format. All right. So the next step is we wanted to take our image and actually split the channels into B, G, and R, and then merge them together and see if we can kind of, learn how can we use OpenCV to actually split and merge the images. Again, all these tools can be significantly used and can be very helpful when we go to an actual project moving forward in the course. So here we're going to load our image using OpenCV, and then we're going to use cv2.split, which is simply we're going to take the image and actually split it into a series of channels, into B, G, and R channels. So shift enter, and if we take a look at b.shape, that will give us the actual shape of the B channel, which is the first one, which makes sense because here we don't have the third dimension because it's just a single channel, right? Next step, if we take a look at the R shape, that will give us the exact same shape, which makes sense. And here we can take a look at the different channels on their own. So let's go ahead and actually visualize the B channel, which is the first one here. So if we say cv2.image show blue channel, and we're going to pass along our blue, and then if we take a look at it, you'll come up with something really strange. Okay, you were expecting to see, let's say, that channel as blue, right? Like at least the color should be blue. However, here you came up with a grayscale image, which makes sense because here when we plot that channel, okay, it's a single channel, it's one-dimensional channel. So OpenCV is interpreting this channel as just a grayscale image, right? Because all the pixels are ranging from 0 to 255. So since we didn't specify that this channel is kind of or this image is a colored image, so OpenCV treated it as a grayscale image. All right. So let's see how can we overcome this. So what we've done here, we say, okay, let's create our own 3D image out of the blue channel. Simply put, we created kind of like a zeros, like an image of zeros, and what we're going to do, we're going to add the blue channel into the first as one of the first channels, and then add zeros afterwards. It's kind of creating our own 3D image with two channels are all zeros because we don't need any colors in the red and in the green. However, in the blue, I'm just gonna pass it along as our blue channel. So as you guys can see here, we created zeros equals to numpy.zeros, and we wanted to simply create zeros with the exact same dimensions as the image. Afterwards, we say, okay, cv2.merge, and here we actually can merge a series of channels together. So we're gonna merge our blue channel, and then we're gonna put zeros in the green and in the red. And that would be our blue channel. Obviously here we're expecting to see at least kind of, some blue color in a way. So shift enter, here we go. So now we have been able to obtain the image, and it has been in a colored format, which looks great. All right, so let's go ahead and see if we were able to actually merge all our original image. So if you guys recall that here we took the image and we performed split to actually split it into B, G, and R. What we could do here, we can actually merge it back again. So we're gonna take B, G, and R, merge it, and that will give us our image merged. And afterwards, we can use cv2.image show to actually show our kind of merged image, which is obviously here, we should get back our original image because we haven't done any kind of transformations to it. What we could do as well, we could merge our original image too, so come up with our original image, but maybe we can, add like an additional kind of, like green to the image. So here, when I'm merging it, I can, I'm adding, 100, for example, to all the green channel. So shift enter, here we go. So now we added kind of, more green to the image, as you guys can see here, because we added 100. Please go ahead and maybe add some colors or some, like a kind of an additional values to all pixels, let's say in the blue and red, and give it a shot. And that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's recap what we have done so far. In this lecture, we have been able to learn how can we do some image manipulations. we learned how can we convert from a colored image into a grayscale image, and we learned how can we convert from a colored BGR image to HSV, and we learned as well how can we perform some splitting, so splitting the actual image into different channels and merge them back again using split and merge within OpenCV. So what we have done here, we loaded all our libraries, as you guys can see here. Here we loaded our image using OpenCV, and then here we visualized some of the shape of the image. We plotted the height and width. Here we show the actual image. Afterwards, here we learned that OpenCV, when it loads the image, the order of the pixels are actually different. Okay, so if we use OpenCV to load the image and we use OpenCV to show the image, we're good. We shouldn't see a problem. However, if you use Matplotlib or any other package that is not OpenCV, okay, or it's not kind of contained within OpenCV, you will see the colors have been messed up. But don't worry, the image is still intact, everything is good, it's just the order of the B and R channel have been swapped, basically. Afterwards, excuse me, afterwards, we took the image, we actually kind of visualized a certain pixel within the image, and then we converted using OpenCV from BGR to gray, so that's our grayscale image. And afterwards, we took our image, we converted from BGR to HSV, as you guys can see here, and then we visualize the different channels. So we visualize the hue channel, we visualize the saturation channel, and we visualize the value channel. And then afterwards, we took the image, we split it into 3 different channels, B, G, and R, as you guys can see here, and then we were able to learn how can we create kind of our own 3D image, okay, or kind of 3 channels image per se, by adding zeros to the other channels, and we're able to actually visualize our blue. However, if we just plot our blue channel, OpenCV will treat it as a grayscale image. Afterwards, we were able to take our channels, merge them together, and that will create our merge image. And then we learned if we wanted to add maybe an additional, let's say, green color, for example, by adding a couple of, kind of an additional values to our pixels by adding, let's say, 100, and that would convert it as well into kind of more greenish color image. All right, that's pretty much all what I have for this lecture. I hope you guys enjoyed it, and see you in the next lecture.